Dear students, this is our 36th lecture on named reactions, and in today's lecture we will discuss about acetoacetic ester synthesis. Acetoacetic ester synthesis is basically an alkylation reaction where the ethyl acetoacetate will be alkylated at either 2 position or at 4 position, depending upon the kind of conditions used for this transformation. So basically what happens is that if the CH bond on the C2 carbon, they are more activated because of the presence of these two electron withdrawing groups, that is carbonyl groups which are attached. So therefore when this reaction is reacted with the base, because of the presence of these two electron withdrawing carbonyl groups, the protons present at this second carbon, they are very acidic and they can be removed very easily, and in the presence of one equivalent of base with the abstraction of one proton from here, this acetoacetic ester is converted into this type of enolate. Now this enolate on reaction with the alkyl halide undergoes alkylation to give us this type of product, and when this alkylated acetoacetic ester is further treated with one equivalent of the base followed by one more molecule of the alkyl halide, then double alkylation at this C2 carbon will take place, and on hydrolysis of this ester followed by decarboxylation, we will get dialkylated acetone derivatives as the product. So this is the process when we are using one equivalent of the base followed by another equivalent of the base. So we will get dialkylated acetone derivatives. But if we are using only one equivalent of the base followed by reaction with the alkyl halide, then monoalkylated acetoacetic esters will be formed, and these monoalkylated acetoacetic ester derivatives on hydrolysis followed by decarboxylation, they will lead to the formation of monoalkylated acetone derivatives. So this is how the enolate can be converted into monoalkylated acetone derivatives or dialkylated acetone derivatives depending upon the conditions which are used for this transformation. Similarly, this monoalkylated acetoacetic ester, when this is reacted with sodium alkoxides in iodine, then followed by hydrolysis and decarboxylation, we will get these types of gamma diketones, and this reaction is basically a base catalyzed coupling reaction in the presence of iodine. So this is another type of product where we can get gamma diketones as the product. Now if we use an excess of the base instead of using one equivalent, then what will happen? Because of the presence of an excess of base, the corresponding dianion will be formed. So one proton will be removed from here and one proton will be removed from here, and you will get enone of this type, enolate of this type. Then one proton from here will be removed and we will get an enolate at these two positions. So a dianion is formed, and when this dianion reacts with one equivalent of the alkyl halide, then the attack of the alkyl halide will take place at this carbon, and we will get these types of monoalkylated acetoacetic ester derivatives, where the alkylation will take place at this carbon, not carbon 2. And these products on hydrolysis followed by decarboxylation will again lead to the formation of monoalkylated acetone derivatives. So this is how, depending upon the reaction conditions, we can different types of products through acetoacetic ester synthesis. And most commonly used bases in these types of reactions are sodium hydride, sodium alkoxide, lithium HMDS, and sodium HMDS hexamethyl phosphoramide, and then these types of dicyl methyl amides, they are also used as the base. So all these most commonly used bases, that is sodium hexamethyl disiloazates and lithium hexamethyl disiloazate, they are very effective in these types of conversions into alkylated products. Now as far as mechanism of this reaction is concerned, as I have told you that the proton present at the second carbon, they are very acidic because of the presence of these two carbonyl groups. So base will abstract this proton and an enolate of this type will be formed, which is a resonance hybrid of this type of carbanion, and this carbanion will act as a nucleophile and undergo bimolecular nucleophilic substitution reaction with attack from the back side of the alkyl halide with the removal of halide, and we will get these types of monoalkylated acetoacetic ester derivatives. And these acetoacetic ester derivatives, where alkylation has taken place at second carbon, they will undergo addition of water as a nucleophile. So hydrolysis in the acidic condition will take place, and we will get these types of beta keto acids. And when these beta keto acids, they are heated, they undergo decarboxylation to get converted into these types of enols, and these enols, they undergo keto-enol tautomerism to give us monoalkylated acetone derivatives as the product. So this is the case when we use one equivalent of base for these types of conversions. Then applications of acetoacetic ester synthesis is manifolds in many types of organic reactions. For example, the substituted acetyl furanes, they can be synthesized by alkylation of tertiary-butyl acetoacetate. So this is tertiary-butyl acetoacetate, and if we use 1.1 equivalent of sodium hydride as a base in tetrahydrofurane as the solvent at low temperature of the order of 0 degree centigrade. So what will happen? The proton will be abstracted by the strong base sodium hydride at this position, and an enolate will be formed, and the carbanion will attack at carbon 2 at the alkyl halide. So alkyl halide used is methyl 5-bromo 4-oxo-pentanoate, and after 12 hours of the reaction, this will be converted into monoalkylated derivative, and this monoalkylated derivative undergo cyclization in presence of trifluoroacetic acid to get converted into the acetyl furane derivatives like this. So 87% of the product is formed after hydrolysis of these esters. So these furans, they can be prepared from beta ketoesters and alpha halo ketones, and when beta ketoesters and alpha halo ketones they are used, then this reaction is known as Feast-Benry reaction. So you can see this is beta ketoester, and this is alpha halo ketone. Then these types of reactants, they can also undergo a second alkylation at the C2 acylated carbon. This is C2 alkylated intermediate, and if we will use an excess of the base, then 2,2 disubstituted products they will be formed, and they on treatment with TFA will give us tri-substituted furans as the products. Similarly, if we are using an excess of the base, we know dianions they are formed, and formation of dianions can be used for the novel synthesis of tetrahydrofuran and tetrahydropyran derivatives, which can be synthesized when these types of dianions of acetoacetic esters they are reacted with epibromohydrin derivatives. And here the base used is lithium perchlorate, and two equivalents they are used, that means an excess is used which will create a dianion, and this dianion will either add on to this C4 carbon and we will get these types of products, or it will add to the C2 carbon followed by cyclization and we will get tetrahydropyran derivative. So a mixture of tetrahydrofuran and tetrahydropyran derivatives will take place. Then similarly this reaction can be extended for the synthesis of 1-aza bicyclo 530 decane systems when double alkylation of ethyl acetoacetate using this type of dianion which is formed from ethyl acetoacetate is reacted with these types of alkyl halides, and again they will undergo monoalkylation to give us these types of products. So first alkylation take place like this, and when this monoalkylated product is reacted with another type of alkyl halide, then we will get these types of dialkylated products, and then these dialkylated products they will undergo basic reaction for the cyclization of this group, and this will lead to the formation of these types of alpha beta unsaturated cyclic ketones, and with further reactions these precursors they can be converted into 1-aza bicyclo decane systems. So ethyl acetoacetate alkylation can be used for synthesis of different types of heterocyclic, and these types of reactions they can be used for development of core structure of stemonoalkaloids. So these are the references which have been used in the preparation of this lecture. Thank you very much.